Hello everyone. In this video, we will discuss concept of reproduction. So reproduction is nothing but from the given solution, finding out the bestest solution or give rise to the best solution. Fitter individuals from population are selected for mating and propagating their features to the next generation. Now we will discuss what are the various operators. There are various operators like crossover operator, reproduction operator and various crossover techniques. So we start with the crossover operator. Crossover operator is applied to mating pool with the hope that it creates a better offspring. So whatever selection we have done, the parent we have selected, those parents undergo the crossover operation. Now we will discuss what is meant by reproduction operator. The reproduction operator selects at random a pair of two individual strings for mating. That is, you can see we have a population. Population means what? Number of solutions. And what we have to do? We have to find out the optimal solution. So we randomly select two parents, or we can say two substrings or two strings from this pool. We call it as a reproduction operator, and these two strings then undergo the various process. The first process is nothing but a crossover. That is, we apply crossover operator to the selected strings. Okay, now we will discuss various crossover techniques. The first technique is a one-point crossover. In this technique, a random point is selected and the tails of its two parents are swapped to get new offsprings. So we have selected two parents P1 and P2, or we can say two solutions we have selected, and now we are applying one point crossover. So a random point is selected. We have selected this position, that is after 4 we have selected a crossover point. So for both the parents, you can see here 0, 1, 2, 3, 4. It is as it is, and this 5, 8, 9, 4, 2. This is also as it is. But what we have done after 4, this part I have put here and this part I have put here. That is, I have done a swapping. So this is a concept behind crossover, one point crossover. And why we are doing this crossover? Because we want something new in the next generation. We want some best combinations so that we should get a fittest solution. So this is a one point crossover. In case of multi-point crossover, likewise we have selected a single point. Here we have to select multiple points. In this case we have selected 2 points for crossover. Now see the result. Here 0, 1, 2 and 5, 8, 9 are as it is, but these two things are swapped here. That is, this 3, 4, 5 are in the next parent now, and this 4, 2, 1 are in this one. We call it as a offspring. These are the parents, and after crossover these are the offspring. And this is a 6, 7, 8, 9 and 5, 7, 5, 7, 5, 8 will be as it is. So this is how multi-point crossover is done. In case of uniform, the next type is the uniform crossover. In a uniform crossover, we don't divide the chromosome into segments, rather we treat each gene separately. In this, we essentially flip a coin for each chromosome to decide whether or not it will be included in the offspring. So this is like a random method, and we will use some values will be used in the offsprings and some value will not be used in the offspring. The next one is the inversion and deletion operator. So in case of inversion operator, the original sequence of string will be inverted. You can see here 0, 1, 0, 0, 1, 1, 1, and we are using the inverted sequence here. And in case of deletion, some of the bits of the string will be deleted. So 0, 1, 0, 0, 1, 1, 1. Here this last 3 bits are deleted here. Last 2 bits are deleted here. Okay. So 2 or more bits can be randomly deleted. Then next we will discuss the mutation operator. After crossover, mutation takes place. So the after crossover step is over, mutation takes place. Mutation changes randomly the new string. For binary encoding, we can switch a few randomly chosen bits from 1 to 0 or 0 to 1. So whatever original offsprings we have, what we do, we select some random bits and we change those bits from 1 to 0. So you can say this is original offspring 1 and this is mutated offspring 1. So here we have changed 1 from 1 to 0 and remaining string is as it is. This is original offspring 2. This is mutated offspring 2. In original offspring 2 we have changed this 0 to 1 in the mutated offspring 2. Only one bit is changed, the remaining string is as it is. And the last one is a bitwise operator. In bitwise operator, we select one or more random bits and flip them. This is used for binary encoding. So here you can see this one bit is flipped to 0. So what we discussed in this video, we started with reproduction, then we discussed various crossover, various operators like reproduction operator, crossover operator. Then we discussed various crossover techniques like one point crossover, multi-point crossover, then uniform crossover, inversion and deletion operator. Then we discussed mutation operator, and the last point we discuss is a bitwise operator. So that's all for this video. Thank you for watching and don't forget to like, share and subscribe.